We are in
We are in. We're
on
live.
my side, at
Okay.
least on my side.
Well, welcome if anybody's watching or coming in. I'm just gonna let it do this.
Give
You're
it,
in. You're in.
give it like a minute or so.
Yes. So we'll give everybody a second who may be joining.
Oh, and let's go ahead and jump in the chat.
Yeah. But today we are discussing cameras and camera settings and things of that nature, as well as a filament eruption that happened yesterday. It was yesterday, right?
Yesterday morning,
Yeah,
I want to say.
my weekend of being at the track for 20 hours the one day, I'd like the day is the same.
It's been one long day since Friday, basically.
Yeah.
Or
So I
wait, you
know,
left Thursday, right?
yeah, Thursday. So I know there was a filament eruption. We're gonna go over that because we have a G2 watch out for it. So we figured this would be a good time to talk about it. That's gonna be step one. And step two, we'll talk about cameras. But I got some sun on my face. Hopefully everybody can see like
It
I
still
was
does look
not
red.
I was not a vampire anymore. I went out in the sun for 2 whole days.
That is more than I can say, actually. It might just be the camera, but I do look pretty white in here.
Yeah, as astrophotographers, we're just out at night all the time, so we don't get much sun. So this was different. Um, I'm sure it'll fade. It'll fade in a week, so I'm ready for it.
You're lucky to get a week out of sun normally. It's, in my experience, you're burnt for like 3 days and then you fade immediately back to white in a day or two. That
Yeah.
might just be me, but also, hi, Sue. Thanks for joining.
Hello. I'm excited. All right, so I'm gonna actually let me give you permission. So that way we'll start off with what's going on currently. And then of course
We'll go
we
ahead
did a
and dive into the
test.
activity.
There we go. Okay.
I'm in. All
We're in.
right.
Let's talk space weather.
So I do want to bring up, at least since we didn't get to quite cover this or didn't have our episode on Saturday, Sunday, the super freaky, weird impulse we got that a lot of people freaked out about that, of
Oh
course, North
yeah,
America
that's right.
benefited in no way.
That's
We
right.
had September 4th, which, what was that, Monday morning, if I'm not mistaken? Oh, it was
Uh
Wednesday. Okay. Wednesday morning. Let's see. This was 9:30 UT, so it would have been just yeah 5:30 a.m. in the morning here in the East Coast. Of course, just after it started getting dark, we see a very big impulse, and I'm talking this one up to 24, 26 nanotesla at the very beginning. That is generally assuming there's any sort of decent negative DZ G3, G4 levels if it's consistent. However, given that the cause was from the side CME that we had on the east limb, which I believe I went over at least video wise on our last stream to show it was a pretty cool eruption, looked awesome. CME looked wide, but really we weren't sure we were going to get anything from it. Well, we
right.
were slightly wrong. And I do mean slightly. We
Mhm.
had approximately 18 hours from the point where we saw the BT level hit 24 nanotesla until it got below 10 nanotesla again. And unfortunately for everybody except for those in high latitudes, which Adrian got some pretty good shots. Don't know if anyone was able to see
He,
those.
he always does.
I mean, let's be fair, he's generally the person to go to if you want to see cool shots, regardless of the day. And he knows how to find the aurora.
Yes.
But there's no real negative BZs. So we had very much no middle latitude aurora whatsoever. All of the activity was very much in high latitude that day. Alaska did get to see some sunrise aurora that day. Lots of purple. That was pretty cool looking. Watching the poker flat cam. That was also pretty fun. But the idea was there really wasn't much to push things until really we had like a 5 minute period of negative 10 BZ, I want to say. Something close to that. Might have been a small substorm there. Didn't really look throughout that day because it was in the middle of the day for us here in the US. Sorry, Southern Hemisphere. So that was that. Since then, we've had nothing. It's been fairly dead. There is a chance, and I do mean a chance. I'm going to zoom in here. We had a kernel hole stream that was supposed to be coming in. We had a slow increase in VT over the last 24 hours, as well as a small increase in solar wind speed. This is Discover, so some of this data is kind of bad here. But we did have kind of a switch. The polarity of the kernel hole was positive, so what we would start seeing is this line being from the blue to the red. There was some intermixing, but ultimately it does not look like we're going to be getting much, if anything, from it. Which again, we're in the midst of solar maximum. This is not at all out of the ordinary. So we'll start seeing coronal hole influence more commonly over the next probably year. But until then, I would say if we see some coronal holes on the disk, there's a decent chance we're either not going to see much from them because of CME involvement, or they're just going to close or change before they hit the Earth. Of course, it might not be that every time, but that's what I would expect over at least the next several months. So that's at least geomagnetic and solar wind activity. Not a ton going on there. As you did mention, though, we did have a filament eruption, which I have a lovely video of right now.
Yeah,
This
it's
is
pretty.
looking at the corona and the chromosphere. So little tiny filaments here all throughout the sun, and then you get some of the coronal loops coming through as well. I want to say it was this one right here. So let's play it.
Like, whoa.
Yeah, and then it starts to destabilize because a group is starting to emerge over here, which that was fun to watch. You could see the flux come in if you do the magnetogram view, and then
Oh,
boom.
look at that. Look at it twist.
Yeah, this was a very cool example of how filaments look when they erupt. They twist around, and then you get the post eruption arcades here, which are also pretty fun to look at. So that's CME. I did not load Glasgow. Let's go ahead and pop that up really quickly. That CME was partially Earth directed, not by much. It was primarily to the northwest, but there was enough of a component that it started skirting through the Earth sun line. So I would expect to be hit by the southern edge of that. Might not see a flux rope. It looks like it was pretty angled, but it's still possible. There should be some southern BZ if we get that. That's my at least estimate with the forecast I was able to look into. Not to say that that's going to be factual, but if we at least see a flux rope, there's a decent chance it should be a southeast north one. So some southern component. And again, that is dependent on if we get anything at all. But the CME itself was pretty faint. There were three CMEs before that, one to the southern edge, one to the west, and then the one that we saw here. Honestly, the running differential imagery is so much easier to see it come out. But it was still a faint one. That's this whole area here.
Yeah, it's hard to see when they start overlapping each other.
Yeah, and it gets pretty faint once it gets out there more, but at Glasgow C3, it just barely starts going south of the Sun-Earth line. So there's a decent chance of a hit, depending on if anything influences it in the corona. I guess we'll see. As everyone has seen, I'm sure there's G2 warnings out right now for the 11th and G1 watch, I believe, for the 12th. A lot of the models, especially the NOAA and NASA ones that came out with the NLULs, are forecasting it with a coronal hole stream that did not show up thus far. So there's a good chance that will not be propelled, which means the CME arrival will probably be later rather than sooner. I would expect more so midday to late day, the 11th UTC time. So probably the night of the 10th to North American morning in the 11th, as is per usual with us.
As
But again, we'll see.
all right. So
And that's what I got.
do you have an example of a coronal hole you can bring up or real quick? So
See, I can
Janelle's
bring up the
asking,
previous one.
yeah,
Sure.
bring up that like Janelle's asking about how you know where high speed stream is, and it's really finding coronal holes.
Yeah,
So
so they look dark when you're in the corona. So let's get
yeah,
out of
yeah,
viewports
like that
here. We
dark
don't need
spot over
Glasgow
there.
either. Yeah. Oh, okay, let's push this back by at least a few days. I would like to bring up some better examples, but I don't remember how long ago we would
Right.
need to go to actually see some. So
And that,
let's
yeah, that
go.
should be good enough because it's really just finding the darker. I mean, they're not really holes; they're just cooler temperature. But they visually look like a hole.
There is a very fun Fox News article. Actually, I had a part to play in this one too back in 20, I think 13 or 2012. Fox News article came out about a coronal hole, and the person that was describing it called it a literal hole in the
Yeah, it's
atmosphere of
like
the sun.
there's no
It's
hole.
not what it is. It's less dense, therefore it's darker. That's an open magnetic field area of the sun. Solar wind is traveling out of that, so therefore there's not a lot of it to reflect or emit light. In this case, emit, and so it's dim, at least in comparison to the plasma around it. Same reason that sunspots are dim. They are still hot, but they're cooler than the surrounding plasma, so they look darker.
And
So
because
they're
of
not holes.
open field lines, that's why the stream is a high speed stream. But
Yes, they're being accelerated outwards in order to cause that. Oh, did I not change that? Whoops.
just
Sorry, I thought I had changed that to be much earlier so we could get
you're fine.
something. Ah, there we go. Yeah, that's kind of good, I guess.
Yeah.
Unfortunately, solar maximum coronal holes are fairly irrelevant on the up phase at least. They disappear more and more as the corona changes and as the polarity swap. But ultimately, this area right here, if it were any bigger, and these things can get huge. I mean, we're talking they can cross down from the North Pole or the South Pole of the sun and go and stretch into the center area.
Yeah, we
those are the ones you will see some geomagnetic storming
we
from.
had some good ones. It's really solar minimum. It's where you start to see these bigger coronal holes, and we had some really good ones coming out of it. Like the whole like Christian was saying, like from the basically the north to the south, like it just crossed the center, and you can get some really good aurora out of that.
Tell
Um,
you what, if you want to go ahead and jump to the camera intro while you're sharing your stuff, I will continue looking for a good example of a minimum kernel hole.
okay, yeah, because yeah, I mean that's pretty much all we have to say on the forecast is like there's a G2 watch out for the 11th, so be on the lookout.
Some aurora.
For some possible aurora. I mean, we'll see. It seems like every time I downplay something, it ends up being really good, and then I gotta like reel that back in. It's like, oh, well, maybe I'll
And then
shut up
decide if you're
now.
traveling.
Yeah, it's like, oh, well, that was better than we thought. But we've had
Yeah.
some good filament stuff from the filament, so
Filaments in the past notoriously have been slow as heck getting here. I mean, I'm
but
legitimately late
like
11th, but they pack. Yeah. I'm fully expecting the impulse to be something close to 20 nanotesla. I'm completely guessing that, but I don't have anything to back it up.
yeah.
But it's a filament and it's something we're not expecting much from. Therefore, it's probably going to be something we would have expected
Therefore, it's
something.
probably gonna be good. So
Yeah,
yeah,
exactly.
there's your warning. All right,
Take it
so
as you will.
on to our other question. Why do you get them more during solar minimum? It's because you don't have all the sunspot groups that are twisted up. So they really,
Corona is much more behaved, or the
yeah.
global magnetic field of the sun in general is just more behaved and acts as a standard, kind of a bar magnet in a way, which then is more conducive for these coronal holes to stick around. And I mean, they'll stick around for rotations multiple. They'll
Oh, they
come
will.
back religiously every single 26 to 28 days.
I want to say the one in 2019, we had Aurora almost every month. So coronal holes are kind of fun because you talk about how you can't predict Aurora, but if you have a coronal hole and it's the right polarity, because like they can be positive or negative polarity, and depending on which season it is, so hold on, snap. Spring is negative, autumn is positive. So we like right now we
Love that
want
phrase.
positive polarity, and the way it connects with our magnetic field is this is we're gonna get into this. This is the Russell McPherson effect. And this has been asked about, so we decided that next week we're going to talk about the Russell McPherson effect and why these different polarities become more relevant in the spring or fall. So hold that thought, we'll get to it.
Actually, I'm just going to go ahead and reshare because I already found it. It's not
Okay,
a.
good.
I went back to solar minimum of this year
Yeah.
just for the sake of fun. Now, note, this is the same exact image, or at least the wavelengths that I was showing beforehand from the other kernel hole, but this is solar minimum. Look how different the sun looks.
Yeah.
You have
There's
these almost nothing. It looks flat. It looks boring. There's a bunch of dark areas. This is the northern kernel hole. So this is during solar minimum. There's usually a northern one and a southern one that you can see generally different times. Sometimes you'll have ones that'll stretch up into the middle too. But this is what they look like, and they're big. And by look, I mean they're dark, like you can't see anything from them. But they will sometimes be stretching down here, just like this one would be.
mhm.
But this is the solar minimum sun.
Yeah,
So just
it's
comparing it to,
much more
I mean,
behaved.
boring, very boring in my book.
Yeah. So yeah, we'll get more into that when we talk about Russell McPherson, but that's kind of the gist of it. So yeah, anyway. But that was our little stint on that. So we can rant about cameras now. So let's see, let's go into that. Let's see. I've actually made slides so that hopefully it's easier for everyone to read. Instead of all right. Does that work? All right, did I pick the right screen?
Nice title.
Yeah. Camera lenses, colors, and settings. Oh my. Yeah, because we get asked about this a lot. And a good deal of it is kind of uh interpretive because as we talked about last week, we don't see very well at night. Like we don't really see colors, we don't see like all that stuff that's in the sky. Um so some of this is really up to interpretation, but we're going to go through a little bit on this. Um Camera brands, for anybody who's brand new to this, we got cell phones, digital SLRs, mirrorless. Cell phones have gotten good enough that it can take pictures of it, like the Milky Way aurora. So most people just use their cell phone. I mean, you are going to be limited because the sensor in a cell phone is like this big, not big,
If that.
tiny. So you're kind of limiting yourself, but I mean, it's the algorithms have gotten really good where it can take a picture, it can to stack pictures for you. That's actually how it works. And why like you can take a picture of a sunset and it looks like just like you're seeing it because it did the HDR for you. So that's kind of cool. But the digital SLR is kind of on its way out. Those are your old mirrored cameras. They're definitely not bad. Anybody that's using them, they're relevant. They still make, you still get great images out of them. But the whole industry is moving towards mirrorless cameras. They're lighter and they just you can the way it's interesting because of taking the mirror out, you can actually set the lens closer to the sensor itself. So now you can develop lenses with these crazy apertures, which we'll get to in the next slide. So there is definitely some advantages to getting rid of that whole mirror setup and just having a sensor there. Um, the lighter aspect is really cool because, if you're a hiker, you want to go to these places, you want to save every ounce counts. That's what they say. And it really does. So yeah, and then any of it's good. I have a Sony and a Nikon personally. Christians, you got a Canon, right?
Yes,
So yeah,
which fairly light.
you're one of those people. Well, that's okay. I'll forgive you. I'll forgive you.
I
Um,
started with Canons.
yeah, they're fine. Like none of them, they all make great cameras. I can't say I'm brand loyal. I'm not. I mean, I have a Nikon and a Sony.
Brand loyalty is kind of silly when your goal is just to do art.
Yeah, they all it comes down to preference. Like each has things about them that I wish the other one had. The Sony has something called bright monitoring, which is really cool because you can set it where it shows even at night and it'll like boost the ISO really high so you can kind of compose. Like you move your camera and you can see what it's seeing. And that's something that Canon and Nikon doesn't have. But the Nikon had focus stacking, which Sony now does, but it didn't at the
Cool
time.
feature.
And I miss the focus stacking, automatic focus stack. I miss it greatly. I really do.
I mean, that's a convenient thing and
It
not fun to do in Photoshop either.
no. So I still use the Z6. I call it my lazy camera because it does automatic focus stacking. It also automatically focuses to infinity, which when you're out there and trying to focus on stars, this will automatically go to infinity. And so like I can just drop it and I'm like, okay, it's fine. But
Useful in -30 weather.
yeah, it's very useful. The only downside is that function only works on native lenses. So if you adapt a lens to it, you lose that functionality. But I have one native lens for that camera.
Ouch.
It
So
is fine.
pros and cons.
Yeah, and actually we'll do lenses first, so we'll go back to ISO and variants since we're on the cameras. So speaking of lenses, I put an example in here. Um, Nikon has a lens for the mirrorless stuff that has an aperture of 0.95. It's insane. Um, and and that's because they got rid of that whole mirror setup so they can set this lens closer and they can make these crazy apertures. But typically you're dealing with f2.8, what you want for nighttime. That's what you're going to find in a lot of the zoom lenses that are out there. You start getting into prime lenses, and the difference there is a prime is a fixed focal length. You can't change it. It's a 50 millimeter, that's all you got. 35, that's all you got. Um, However, it allows you to get into these f-stops that are a lot that less than 2.8. So that opens up your possibility to do real-time video, which is really cool because you can video aurora, which is I've done it a few times with my f2
So
1.2.
hard.
Yeah, it's really cool. So that's the advantage of having a prime lens. Zoom lenses, I mean, I still love my zoom. My absolute favorite lens is the Sony 12 to 24 f2.8. Um, it lives on the camera really, but I just love that range. And it's a 2.8 lens, it's super sharp. But there are times where, a prime helps you out, especially if you really want to get some real-time video or things of that. Um, you don't get it with the zoom lenses. So now we'll go back to this little topic about ISO and variance, which is kind of the argument as to why Sony and Nikon may be better than Canon. Um, because their ISO variant and Canon's are ISO variant. Um, and now I have to do this. It's basically I have no real difference in the final picture, whether it's shot at, I'll just read it, at 100 or 1600. They're essentially the same thing, except the dynamic range is saved at the lower ISOs. Um, it's an interesting concept. It it really kind of opens up what you can do. Like I've shot things really underexposed, to try to save the highlights, and you can just bring all that back, and it doesn't destroy the image. Whereas like in the Canon, it would be all like noise basically.
Yeah, I'm gonna have to test this out on my side now just to see
Yeah.
which ones are which, but it does look like it's a bit noisier and doesn't work as well.
Yeah, so that's it. And Nikon uses Sony sensors. So that's kind of why, both cameras have this ISO invariance to it. There's a couple links which we'll put in the description that you can read more on it. Um, because I mean, I'm kind of surface level on it. It kind of goes a little bit deeper that like with your ISO invariant cameras, you really want to shoot at whatever its native ISO is. Because that'll just make it better. And it varies on camera. I think mine is 400. And then 800 is the switch.
It's
But
usually pretty low, I assume.
yeah, it's usually pretty low. So I will have to look at that. Let's see. Oh, this is the do the slides full screen. Yeah, probably.
I was
uh
about to interrupt for that.
where is it? I don't want to join a
Probably
call.
just doing the slideshow and see how that works.
Yeah. Oh yeah, let's do that. There we go. Look at that. Ha! Does that so there we
Slides are a
go.
new thing, so we're getting there.
Yeah, it's our new thing. I had a long weekend, and so I'm gonna take responsibility for this, because I should have been more prepared. Or we're more prepared next week. That's why we're unplugged here.
Oh, that's what I was gonna say next. Yeah, we're unplugged, not everything's trained and ready to go.
I mean, like I think what was it? Saturday? Yeah, Saturday I spent basically 20 hours at the track, on my feet the whole time. So
Literally,
yeah,
right? I don't think there's a basically to that.
the last car went down the track at like 1:20 a.m. or something like that. So yeah, I apologize, but we'll get better. Anyway, off topic. We're back. So what's my okay? That's so we talked about lenses, and then okay, so this is going to be the
Ah, the
fun
white
topic
balance.
is white balance. Um, Typically for most nighttime stuff, and this also is kind of dependent on your camera too, because I've noticed every brand has a slightly different a white balance that you want to stick at. My Nikon's like 3800 for nighttime stuff. The Sony I kind of stick it around 30, it's like a little 3400 I think, and that's Kelvin. That's the Kelvin temperature, which you can when you go into your screen for white balance, they have like settings like cloudy, fluorescent, tungsten, what's some other ones, daylight,
Incandescent,
incandescent, and
I
then
think's one.
there's an option to set manual, and when you go into manual, that's going to be where you can set your Kelvin temperature. And a lot of times I'll have it at like 34 to 3800 for typical nighttime stuff. And that's kind of where I leave it for even the Aurora. I just leave in the nighttime white balance, and then you can adjust it accordingly. I don't get too hung up on it though, because you can fix it in post pretty easily. Um, so I'll set it, forget it, and then if I don't like it, I'll adjust it a little bit.
Yep, pretty much same.
The
Shoot
key,
in raw, everyone.
yeah, shoot in raw. Don't shoot in raw.
Otherwise,
Otherwise you can't do that. So the other thing I wanted to bring up is that there's something called auto white balance. You can do that. You can try that out and see what it does for you. If you do time lapses, though, do not use auto white balance. It will make your life a living hell in post, because it could change between frames, and then you have to try to match all those frames together. So so if you're doing a time lapse, set it to one white balance and leave it there. Um, you can go back and post, and like you can highlight them all and change them if you want to change it a little bit. But yeah, you definitely don't want to do that for a time lapse. You could try it out on stills though and see what it does for you. But and then it changes if you have moonlight or twilight or light pollution, it's all gonna have effect on your white balance. So for those instances you change it around. Lately, so like if I go into manual, I keep it at that 34 to 3800 Kelvin. But I've also been playing around with the different settings, like cloudy. A lot of my daytime stuff I put in cloudy because it adds a warmer tone to it overall. Um, and then I've been playing with fluorescent for nighttime stuff. and it's been kind of interesting. So play
That's a
around
cooler
with it.
one, if I'm not mistaken,
Yeah,
right?
it's a cooler one. It works really good for these twilight blends that I like to do, because it automatically gives the whole scene a more twilighty look with the blue. So that's kind of the artistic interpretation. But I'm going to show you this website here because this guy, Clark Vision, if you don't know Roger Clark, I I recommend taking a look at this website. He's got a big bear on it for right now, but this guy, he is a photographer, camera guy, tech guy. He's worked for NASA for a long time, like calibrating all their cameras. Um, Everything you ever wanted to know about every camera, every lens, he will write an article about it, and it goes really in depth onto everything. But what I wanted to bring up here, and I think I have um the page, is the color of the night sky. Because we're talking about artistic interpretation. Well, Roger Clark has a a page here, and he goes into the scientific colors of what the night sky actually is based on different gas emissions and things of that. So this picture of this is balanced rock in Utah, Arches. This is what the natural look of a night sky is. It's actually very warm, brown, red. And personally, this isn't aesthetically pleasing to me, so I would change.
No, same.
And this is why we want to bring this discussion up because he's more of a scientist, so he will stick to whatever the natural colors are. He will not deviate from it. And if you ever post something in a forum that's blue, it specifically, he will come out and call you out on it because he doesn't like blue Milky Ways at all. Like at all. And he noticed that a lot of people, like, especially when they first start with astrophotography, all their Milky Ways are blue. And I think it's because when we typically think about the sky, we think about blue skies. It's just ingrained in our head. The sky's blue, and even at night, you kind of get that feeling of the bluer tones, even though we're not really seeing color. And then moonlight makes everything bluer. So we're just accustomed to seeing something more blue, not this red orange color that we see here. Um, but this is this I'm going to put this website in the link too because it's just interesting to read because he talks about air glow and what the colors of air glow is like light pollutions. It's really cool. So now let's talk about air glow. So this would be more of the natural colors of air glow. And again, it's a very pretty
Ah,
picture, but do I like the red and green in this? Or
no.
the yellow and green? Not particularly.
It's again, it's not scientifically interesting, but I wouldn't put it farther
Yes,
than that.
it's scientifically interesting. It's a really beautiful shot, but this is your natural colors. Yeah. So if
So
you're
warm.
if you're on the fence, like this is where, if you're more on the artistic side, you're like, well, do you want to take that artistic license or do you want to stay within this is what these colors are? I'm not deviating from it. It's up to you.
It's all subjective.
And I think he has stuff about Aurora too. Yeah, this is Red Aurora
From
in that
Denver. Wow.
color. Yeah. Um it's a lot of red. The night sky is just a lot of the red warmer colors. It's interesting because you see so much of the more bluer tones. It's very interesting to see somebody say, "Look, there's all this red. Like here's some zodiacal light with some red air glow coming in here." It's just yeah. What else we got? More air glow. Yeah, everything's just warm. It's so warm.
I
And then
like blue way too much to
I know,
leave it out
yeah.
like that.
So
That
then
looks fine though.
yeah, he has some DSO examples in here because when you start zooming in on different it's the Lagoon Nebula. Like you get the blues and stuff because of the different gases that are being emitted. Right, this is Orion.
Orion.
Yeah.
All that hydrogen.
Mm-hmm. More Orion. And then here we go. See, blue night skies? Question mark.
Clearly an issue for him.
It's definitely a sticking point for them. But yeah, this is just a really good. I love this website, so I'm gonna link it so you guys can read about it. But yeah, here you go. These colors are not natural. They're not. Don't do that. Don't do it.
I will say that blue overkills it, and it takes away the air glow too,
Yeah,
which
I
you can see
mean, yeah,
there.
this
But
is like I would never edit anything this blue. But yeah, but I just love it because I just love his disdain for the blue skies. But here's the natural edit. And yeah, like I love having the green in there. I still would have cooled it down personally because I like the cooler, but
a little
it's
bit.
the natural night sky has a ton of red in it. And now we're going to talk about twilight blue. So you know, we all know the twilight colors are more of that blue purple. And that this is where it's permissible. You can have your blue.
Twilight only.
Twilight only. Just kidding. So yeah, it's like in this you everybody's probably seen this, so I'm gonna bring this up right now. The green band in Deep Twilight. Remember on all the forums
Oh
when
boy.
people would post this like right after Twilight and thinking it's
It's
Aurora?
Aurora. Yeah.
So you see it really well on the back of your LCD screen. This green band shows up. It's so what do we got here? It's the Rayleigh scattering. That's what they call it. Or actually, no, it says green band. The green band from deep twilight is air glow from oxygen emissions. So in case you ever wondered, that's what that is. And it's why you got to wait till it gets darker to be able to
If
verify
green
it.
is on top of red, something is wrong.
Mhm. Yeah, so
That's how I always think of it.
I love that he put this in here because this gets confused a lot in the Aurora forums. But yeah, it's not it's still yeah, that's all I'm gonna say about that.
That
So
could be a
the
long rant.
yeah. Do-do-do-do. Yep. He's got lots of pretty good examples here.
I mean, his photos are good.
Yeah. So this is pink aurora in natural color. You can see it up in the top there. But yeah, it's just everything is just way red. So that's that. That's my natural color of the night sky. It's a lot warmer than we all thought it was.
So use that to your discretion.
Yes.
Want to make it more accurate, or keep the artistic license there,
Yeah,
which
keep the artistic license.
it's
I
for
think
everyone to choose.
so my last point that I have, that we'll go back to sharing the screen here, is about oh yeah, I guess we should talk about settings. I went all into the natural
This stuff.
the light thing, but so what I usually typically tell people to do, and this is regardless, these are your basic typical night starting points, and it'll get you an image, and then you can adjust accordingly. So it's like f2.8 60 ISO 6400 15 seconds. I mean 50 seconds you're probably going to get some star trailing, especially on these higher megapixel cameras, or if you're using a lens that's not so wide, like say like 50 millimeter, 35 to some extent. I think my 35 trails around like actually trails around like 6 seconds, I think.
Rule of 500. That sounds
Yeah.
right.
It the yeah that and then that gets tweaked a little bit because the higher megapixel you have, the trailing starts sooner.
Makes sense.
Yeah, so it's like
All those different light buckets.
yeah, all those different light buckets. So, but for a starting point, this will get you there. On a moonless night, if you have a moon, it's gonna be you can drop that ISO to like even 400, which I've shot at under a full moon. Um, but Aurora can be very bright and dynamic. So this is where you talk about how you want it to look. Do you want to capture those pillars, those straight pillars? Then you want something like, especially in a big storm. I mean, you could do like a second. I've shot it at like a second or less in those really big storms. But typically, it's in the 8 to 10 second range is where I keep it. You know, something that's moderate. Um, and then really low level activity, you could even push it, especially if you have a star tracker, which I'll show an example of where I've done like 1 to 2 minute on it. But I don't know. What have you found? Do you shoot at like 8 seconds?
So average aurora I find anywhere from 6 to 10 seconds. Like this Corona behind me, that was 2 seconds though. It was just bright enough to the point where I was doing anything more than three or four, and I was getting smeared lines instead of just the pillars as they were.
Yeah.
So the May storm, I think I didn't go below 2 seconds. I'm pretty sure I stayed in that realm.
Yeah, I think I was I well, I wasn't thinking clearly that day, but I think I was around 4 seconds. because it was probably a little longer than I normally do. But yeah, I mean
I
those
was
big,
also getting through light pollution in my area.
yeah,
So
yeah,
I couldn't do too much longer without it suffering. I noticed.
yep. That's that moonlight, light pollution, things like that is going to affect it too. So you can either drop ISO or up the aperture or drop ISO, make it longer, make it shorter, put um I can't even talk today.
Well, close your aperture. You're
Yeah,
tired. You got an excuse.
put the ISO to the moon. You got ISO variant camera, just go to the moon. 12,800, do it.
I think I've used that maybe 2 or 3 times. I was on a plane too. Oh, my plane
Yeah,
Aurora.
yeah, plain
Didn't have a
Aurora.
tripod, so it was like
Yeah,
ISO
12,800,
25,000,
1 second.
like 25,000 half second. Let's see. Yeah, stars are kind of moving still.
You
Yeah,
know,
plane Aurora is hard.
Photoshop has this neat Topaz AI thing, or not Topaz, well, Topaz denoise, but Photoshop has that dynamic noise reduction. So yeah, 12,800 to the
Just
moon.
go for it.
So we'll talk about that. And now we're going to lead into the megapixel discussion, which I kind of alluded to on the previous slide. If you have a camera with a lot of megapixel, like 45, I mean, some of the Sonys are like 61 now. Um, the stars are going to trail faster, even on a wide angle lens, and they're noisier. And that's due to having all these little tiny pixels, so they're tiny little light buckets. Um, so they don't capture as much light. So you have more front end read noise. So these images that come out of these big megapixel cameras, which are fantastic for, daytime
Daytime.
photography or like even wildlife or what I was shooting this weekend. So you have this whole screen, you can crop it right into this little tiny thing. And it doesn't matter because you have all these megapixels to work with. But at night it becomes a problem. So I've found that the cameras between 20 to 30 megapixel is kind of the sweet spot. You have something that's decent in megapixel range to begin with, but you have more range, like it's just so much easier to deal with at night because it just handles the noise so much better. Like my A7 IV is 33, my Z6 is 24. What's your camera?
So I will say the R I think is 42,
Okay.
and then
Yeah.
the T7i I had was 16, maybe 18.
Yeah.
And really, the night sky images on that were cleaner in general. I don't necessarily know. I like the detail better on the R, but I've noticed that trying to get a cleaner sky out of it is far more difficult at night.
Yeah, so it's interesting. Like I made the mistake when I first got into this. I mean, I thought it was the first new camera that I ever bought, and I was like, well, I might as well buy the latest and greatest thing that's out there. So I
Yep.
bought an Nikon D850. It was 45 megapixel. The camera was freaking awesome for everything. I loved it. But I did notice when I used it in the Z6, which is half the megapixel, I liked the images out of the Z6 more at night. So I ended up retiring the 850 as like the daytime camera, and then the Z6 was the dedicated night camera. That poor 850 met a demise at Thor's Well in Oregon when it got hit by a saltwater wave, destroyed it.
Yikes.
So that's when I became a Sony shooter.
That's fair.
Because I had to replace it with something, so I bought an A7 IV. But that's the story behind that camera. It was great, but it was a high megapixel camera, so I had to deal with, the limitations of it. And
If
that,
only cell phone cameras made the same realization because now we've got all these Samsung cameras and or Samsung phones with high-end cameras and they're going up to 40, 60 megapixels. And then you realize that if you compare those phones with the older S7, S8, S9 cameras, the night shots suck a lot. There's just so much noise you can't get any useful information out of it. So if you've got any newer phones generally, and that's another reason why iPhones are kind of winning when it comes to the night sky stuff, their cameras, the actual sensor quality hasn't improved too much. They've gotten a little bit bigger though, whereas Samsung just keeps packing megapixels in their cameras, but now they're really noisy. They look really good in the daytime with light, but the nighttime stuff is just bad.
yeah. So that's what we got on cameras. I'm gonna look at the chat real quick to see if we have any more questions to look at.
Lots of commentary.
Yeah, lots of commentary, which is good commentary. I like.
Oh, Justin said that LR time lapse apparently can compensate between light
Oh,
balance
well,
differences.
that's good. I think LR that program can do a lot. I mean, I haven't done too many time lapses, but the few that I have and put it through LR time lapse, it's it's definitely like kind of the bar for
I think
time-lapse
Vincent
stuff.
advertised that on his summit presentation
Yeah,
last year
I
too.
think you did too, because it can just compensate for a lot of things, and it can smooth out the motion. It can figure that out.
I have
Um,
still never done a time lapse.
I guess you're gonna have to. I mean, at least I've done a few.
I need to at least do one, but
So I'm gonna bring up some examples. I've pulled some stuff from different Aurora things that I've done. So we'll go back to screen one, share. Okay, let me see. I got some Aurora examples here. It's funny. I'm so disorganized that like, oh, I gotta find an image, and then I can't find it. So then I go to Facebook
wonder
and
why.
pull it off of Facebook, and now I all these have these weird file names because yeah, I pulled it off of Facebook. So but the one I wanted to show is this one in particular. Because let me see if I can make it bigger.
That the tracked one.
It's a tracked one. This is a blue hour blend because there's actually a lot of lights around this lighthouse that annoy me, so I blue hour blended it. But
Fair.
I was tracking the sky anyway, so it didn't matter. But this was a 2 minute exposure, and the aurora wasn't super active, but it was active enough. You can see the pillars, but you can see how that's kind of like really smooth. It almost has an undulating effect. Um, but what's neat about it is you could start to get the air glow really good with the tracked shot. So like over on the left hand side, you can see the air glow coming in. So I thought that was kind of cool.
That's cool.
It's a different look, but you can definitely use your tracker for Aurora at times. Let's go back to another one. Oh yeah, I'll show you my tracked Steve, which was one of those A pods.
Oh yeah.
Some people have
Still one of
seen
my
this,
favorite photos.
but what's interesting about this is 5 minutes worth of data on a Steve, and you can just really see the details that are coming.
Did you know Steve was there? Were you actually
Oh
shooting
yeah,
for it or
I knew
did
it
it
was
come
there.
out? Okay.
It was very big. Here, I'm gonna zoom in on it so you can see. And it was across the whole sky, like it went from horizon to horizon, and it just stayed there. So that's why I was like, you know what? I'm just gonna track this because
That's
it's
so cool
not
the way the
going
sky
away.
turned out too.
Yeah, and I just love how it got this twist, like this little twist right here. I don't know, it was pretty cool. Um, but as you see, I did, I still I tend to, go on the warmer side to try to stay with the natural sky, but there's some blue in here. So it is what it is. That's reflecting you at me, it's fine.
All subjective.
Actually, this was tracked too. Um, and you can always tell because it's smoother.
Wavy. Yeah.
But that's
Looks like an actual curtain.
yeah, that's a tracked Steve as well. Do I have let's see if I get more examples here. That I want to show anyway. Um, oh yeah, I mean this is an old one, but this was I don't know, 2 or 3 seconds, but you can see how it's got like you
Got
get
some
the
pillar
air.
action.
Yeah, so it depends on what you want to do. You want to keep the action. Definitely go with the slower shutter speeds or faster shutter speed. Sorry, if you want to freeze it and get more detail out of it, then I can't talk. Not freeze it. Freeze is for fast. If you want to
I
just
mean,
get
close enough if you want to freeze the motion. Yeah.
yeah yeah.
Use a
So
faster shutter speed.
this one has a lot of air glow in it.
God, yeah, look at that green.
But it's tracked. This is another. I had this folder's got a lot of tracked images in it. This is I don't know 2 minutes give or take, and the Steve's over here. We got the
I
Milky
still
Way.
need to get a Steve.
Yeah, it's a lot of green. And we're talking about coronal holes, right? Because all of these Steves that I've gotten is from coronal holes.
Interesting.
Yeah, like every one of these was like this was Labor Day 2019 when we had that one coronal hole that made laps and laps.
There's like 3 or 4 different
Yeah.
rotations.
So that was that. This was March from a coronal hole, March 2021. So that was a coronal hole. Yeah, I don't know if I know some people have seen the Steves with this recent stuff, but I mean, I've missed them all. But so everything I have is from a coronal hole. Do I have anything with the faster? I don't think I have anything in here. I'm gonna look at this one. I mean, this was probably 8 to 10 seconds for that. There isn't much there. So it depends on the activity level. If you want, actually this one was tracked too. So
Ah,
there's very minor activity.
SMC Aurora,
Yeah, SMC Aurora, as we talked about. So it's
which that'd be
there.
a good one for trapped. I mean,
Yeah,
you're
it's
just
very good for
adding
track.
data that's still there.
Yeah, so that pink is there, but what's cool is you're getting the air glow to really pop with the track shots. So it could be fun to play with when you have like boring Aurora to work with.
Les has a request
Yes, what's that?
to briefly summarize the last 12 hours of solar wind activity,
Oh yeah. You want it?
which I've got up if you want.
Yeah, here, I'll throw it back to you.
All
Bing.
right, Les. So yes, solar wind, mostly the actual real-time solar wind data. So the IMF strengthens the actual speed. Right now, it's partially mostly a not well connecting coronal hole stream that came in. It's really not that much though. It was a positive polarity, if I'm not mistaken, and the only positive bits of magnetic field we have are these red areas where phi turned into, well, I like how they distinguish between blue being negative and red being positive. But the idea is, I think it's a solar wind stream or a high speed stream from the looks of it, and it's not very much, but it was that center one that was around for a little bit of time.
It was a
Yeah,
little bit to the north, right?
yeah, it wasn't
Yeah.
very geo-effective either.
Yeah.
However, the protons you were mentioning, there were proton increases, not only high energy protons, we're in an S1 warning right now, but we also had low energy protons increase as well. This is from the West Limb eruption. So if we check out, oh, I still actually have Glasgow up, don't I?
Yeah, so you're
There
gonna
was a West Limb eruption.
yeah. You're gonna get the protons from the west limb, basically. It's more connected that way.
Let's see, is it on here? No, I might have to go back further. It was a
Fine.
pretty energetic one though. It was a little bit over the western limb so that you could kind of see it. But it wasn't anything that we're going to get necessarily on our end. Justin, if kernel hole makes a ton of rotation, it makes a ton of rotation. Does it always stay the same polarity? If it's the same one, yes. And generally, the polarity matters in specific hemispheres. So if there's a kernel hole in the northern hemisphere, depending on the solar cycle and what magnetic cycle it's in, it's going to maintain that polarity, yes. Let's see. There it is.
Ah, yeah, that's a pretty big one.
There was two big ones actually. So we had
Yeah.
that super big one on the west limb, and then there was one directly from probably right behind southeast limb.
Oh, whoa, Jesus.
Hmm.
Whoa.
Of course, they're all not facing us. Like at this point, we can't get our big CMEs to save our lives, which is probably good because it would do the opposite of that. But yes, so big CMEs mean big, heavy protons being accelerated, which means high energy, which means goes increases, which means S1 warnings. Or we won't hit S2. I highly doubt it. This will likely start coming down over the next maybe day.
Yeah.
We're at what, 31 PFU? Yeah, so it's got a while before it hit S2. I doubt we'll see much more of that unless we get
Yeah.
another CME.
And the thing to remember too, which we talked like solar energy particles, this is more for like it's the radiation part of it. This isn't gonna do anything for Aurora.
Yeah, this is
But
really just annoying for everybody, really.
yeah, it's
It affects
everything else. Yeah.
polar radio wave communication, and then you got radiation that goes up as well. It's kind of annoying. Ooh, yeah, let's check out. That's a fun thing to look at while we're here, at least. So the normal solar wind chart, I believe it's called trace, heat region absorption. Note how we've got maximum attunization, I can never say that word, up in the poles this time. Whereas normally when we have solar flares, it's the day side that really counts. And we see that start glowing up. So then you've got on the day side of the Earth, radio transmissions and high frequencies start cutting out. Well, at this point, you've got the polar regions now suffering because of those high energy protons that are being funneled in. So that's a fun one to look at. And
Yeah.
those fade slowly. So this has an estimate of about 8 hours before it starts going below any sort of issues, basically.
Yeah. So this is like definitely if you're into what like ham radio operators, any of them, like this is where stuff
Yeah.
becomes a problem.
This
Because
is where not quite where it would be filtered around, like if you do a flight around the North Pole, but if this gets much higher, you'll have flights that get diverted further down to the equator to avoid this area.
yeah, fun times.
I think an X-ray or two if you go through it sometimes.
Yeah,
I
you
can't
know,
remember the actual
well
amount, but
there's a uh there's been some transpolar flights where people's like it defibrillate not where you have implant for heart um that little pacemaker thing like that malfunctions because of high energy particles that have been getting in.
I've heard that
Ju-
happening with cosmic rays too.
Yeah, cosmic rays.
Just randomly cosmic
Yeah.
rays coming in.
And interesting enough, so the cosmic rays are higher in during
Thanks,
solar
Tanya, for that info.
so yeah, we talk about like space flight, like people going up in space, like, is it safer to go during solar minimum? But it's really not, because you have more cosmic rays. So it's kind of like just picking your battle. Like,
Yep.
Me personally, I don't want to go to space because of that. I'm fine. I'm fine right here. I'm
I
fine right.
could implant my eyes to see it, that'd be awesome, but I don't want my actual body to go up
Yeah.
there. It
We
just
have a nice protective layer to, you know, deflect all this stuff out. But as you see, when you fly at 30, 40,000 feet, that you got less of that protection. So like these cosmic rays and these high energy particles can get you. Um, they just can. So that's a nice little note to leave on, right?
look out for the cosmic
Yeah.
rays and the high energy protons.
Yeah.
Get ya.
Watch out. Oh God, no. Anyway, that's what we got today. If you have any questions, let us know. Holler, say hi. Um,
Once again,
yeah.
thanks
Once
for all
again,
the
thanks for
chats
watching.
too.
Yeah, and in the chats. As you see, we're trying to get more to the chats. Because at first I was like, don't look down at your phone. I'm programmed, from working. Like, don't use your cell phone. Don't do it. But,
But we're
I want to,
unplugged,
yeah, I want to see what you guys are doing, and asking about so we can,
and it leads into conversation.
yeah. So it's all good. Keep it going. But
So
next,
Justin, Les, everybody else that pitched in, thank you.
yes. So thank you for watching. Next week we're going to talk about Russell McPherson effect, because it's pertinent because we're in September, and there's been some posts on Twitter that we'd like to address. We have a friend on Twitter that keeps feeding us subjects to talk about.
It
So
is pretty convenient.
that'll be a fun conversation because we're in the fall. We're gonna, theoretically we get better aurora around the equinoxes, and we'll explain why. So stay tuned next week. I think we're gonna shoot for Saturday again.
Yeah, we should. Will we have, you think, regular days coming up
Yeah, we
for
should.
each?
So Saturday, probably around, I don't know, 3, 4 p.m. Eastern. So
I'm
we'll
okay
post
if we
about it.
want to split the difference and do like 5 p.m. or like 4:30, 4 or
Yeah,
something like
we might
that.
do
That
that
way,
because for
Southern
our friends
Hemisphere
down
friends.
under
Yeah.
that we love so much. So we'll leave you guys on that note. Have a great day. Thanks for watching. We'll see you next time.
Thanks, everyone.